Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so our objective for this problem is to find the ratio of torques for two wires in a magnetic field. So we have our equation for torque is number of coils times the current times the area times the magnetic field sine of phi. And we have two different setups. We have a square and a rectangle. And we want the ratio of the square to the rectangle. And we want to find when the torque is maximum, which in this case is when the sine of phi is equal to 1, which we have when phi is equal to 90 degrees. 90 degrees is when our magnetic field is straight perpendicular to our area enclosed by the wire. So when phi is 90 degrees, we have our maximum torque. And our two setups, we have a wire that is in a perfect square, and we have a wire that is more rectangular shaped. So we want to find the ratios of torque. So we have everything's going to be the same in both cases other than the area. So what we'll end up having all of this over the same thing, except we'll have a different area. I'll call that area 2 here. That contributes to the torque. Everything else will cancel out. Our magnetic fields will cancel, our currents will cancel, and our number of coils will cancel. So all we have to worry about are the two areas, and we'll get the same ratio. So what we want is the ratio of the area for the square divided by the area for the rectangle. So let's see if we can relate these two. So we know that our total length is split up into 4 for each side of the square. We'll call our length L. So each one is a quarter, so L over 4, which means our area is one side times the other, which would give you L squared times 4 squared. And we have for our rectangle that one side is twice the other side. I'll call that a lowercase l. So we have one side L and one side is 2L. And we know that all of the sides added together have to equal the same. We know that both lengths of this wire are the same. So the total perimeter of this wire is equal to L, which we have 2L on this side because it's the same side, and then we have 2 L's, which we get these two sides give us 4L, these two sides give us another 2L, for a total of 6 lowercase l. And that's equal to the total length, which also gives us that our little l is equal to the total length divided by 6. So if we plug this in for little l and calculate the area of our rectangle, we have, if you take the length times the width, we'd have 2 times 6l times, or I'm sorry, 2 times l over 6 multiplied by l over 6. So you'll have 2l divided by 6 times l over 6. Okay, so we have our we can get our two areas now. We just need to finish reducing here. So we have L squared for the square divided by 16, which is 4 squared. And we have for the rectangle, we have 2L squared divided by 6 times 6 is 36. So right away, we can cancel out our 2 L's. And this will become 1 over 18. But we can flip it and put it into the numerator here. So we have 1 over 16 times, so flipped would be 18 over 1. So this is a complex fraction. This is just this flipped and then multiplied by the numerator. So our final answer will be 18 divided by 16. And that gives you the final answer. Or you can reduce this fraction even farther. We can get 9/8 is the exact number. And there you have it.